Hi all, in this class we are going to discuss depreciation. Depreciation is the process of spreading out the cost of an expensive item over the years you'll use it. Imagine you buy a residential building. That building won't stay brand new forever. Over time, the roof might need repairs, the paint will fade, and the overall functionality might decrease. Depreciation allows you to account for this. Depreciation. Depreciation is the property's value lost due to its use, life, wear, tear, decay, and obsolescence. The general annual decrease in the value of a property is known as annual depreciation. Usually, the percentage rate of depreciation is less at the beginning and generally increases during later years. Generally, for the first 5 to 10 years, the building or the structure has very little depreciation. Depreciation depends on the use of the building, the age of the building, the type of maintenance, etc. Depreciation is applied to the current value of the building to calculate its valuation. Here are some methods for calculating depreciation. 1. Straight line method. 2. Constant percentage method. 3. Sinking fund method. We will begin by discussing the straight line method. Straight line depreciation, simplest method of calculating depreciation expense. In this method, the expense amount same every year over the asset's useful life. Under this method, an equal amount is provided each year for the depreciation until the asset has been written down to nil or its scrap value at the end of the estimated life of the asset. If the successive annual depreciation over the life of the asset is plotted on a graph, the result will be a straight line with a slope equal to the annual depreciation. This method is also called the fixed installment method because a uniform amount of depreciation is charged each year. The formula of the annual depreciation under the method is D equals C minus S by N. Annual depreciation equals original cost minus scrap value by life in years. This method can be recommended only when the following conditions are satisfied. A. The asset is expected to render a uniform service throughout its estimated useful life. B. Annual repairs and maintenance costs are assumed to remain constant over its life. C. The asset is expected to earn an equal amount of revenue each year throughout its life. D. The amount of depreciation is a function of time only. Repair cost. Repair costs in the later part of the asset's life. A partial rectification of this method is possible by estimating the total amount of repair cost over the life of the asset. The depreciation and repairs are accounted for as a unit. The annual cost would then be annual depreciation equals original cost plus repair cost minus scrap value divided by life in year. Next, let's move on to some examples. Question 1. A businessman buys a 2000 rupees MacBook that won't be useful after 5 years, and its estimated salvage value. He sells it for after 5 years is 500 rupees. Determine straight line depreciation for the MacBook. Answer, given data. Original cost equals 2000 rupees, repair cost equals Rs 0, scrap value equals Rs 500, life in years equals 5 year. To determine straight line depreciation for the MacBook, annual depreciation equals original cost plus repair cost minus scrap value, life in year equals 2000 plus 0 minus 500 divided 5 year equals 1500 divided 5 years equals 300 rupees. The MacBook will depreciate 300 rupees every year. Let's move on to the next problem. Question 2. The present value of the machine is Rs 2,50,000. Work out the depreciated cost at the end of 7 years if the salvage value is 20,000 rupees. Assume the life of the machine is 18 years. Use a straight line method for finding depreciation. Let's start with the given data. We have an asset with an original cost of 250,000 rupees. The repair cost for this asset is 0 rupees, and its scrap value, or the estimated value of the asset at the end of its useful life, is 20,000 rupees. The asset's life in years is 18 years. Now, we want to calculate the annual depreciation of the asset. Depreciation is the decrease in the value of the asset over time due to wear and tear, age, or obsolescence. The formula for calculating annual depreciation is equals original cost plus repair cost scrap value divided by life in years. Substituting the given values into the formula, we get equals 250,000 minus 20,000, divided by 18 equals Rs 0.12778.00. This means the value of the asset decreases by 12,778 rupees each year. Next, we want to find out the total depreciation after 7 years. We do this by multiplying the annual depreciation by the number of years, which gives us total depreciation after 7 years equals 7 multiplied by 12778 equals Rs 0.89446. Finally, to find the depreciated cost of the asset at the end of 7 years, we subtract the total depreciation from the original cost. Depreciated cost at the end of 7 year equals 250,000 minus 89446 equals Rs 0.160554.00. Depreciated cost at the end of 7 years equals 250,000,89446 equals Rs 0.160,554. So, at the end of 7 years, the value of the asset, after accounting for depreciation, will be 160,554 rupees. In this question, an equipment that costs 25,000 rupees, has a useful life of 8 years, and a salvage value of 0 rupees. We need to calculate the annual depreciation of this equipment. The formula for annual depreciation is annual depreciation equals original cost plus repair cost minus scrap value divided by life in years. Substituting the given values into the formula, we get Annual depreciation equals Rs 3,125. This means that every year, the book value of the equipment decreases by 3,125 rupees. So, if we start with an opening book value of 25,000 rupees in the first year, after accounting for the annual depreciation, the ending book value will be 21,875 rupees. This process continues for each year of the equipment's useful life until the ending book value reaches 0 rupees in the 8th year. Consider a machine that has an initial cost of 150,000 rupees and a salvage value of 20,000 rupees after 12 years. We want to find the total depreciation and book value after 6 years using straight-line depreciation. The formula for annual depreciation is annual depreciation equals original cost plus repair cost minus scrap value divided by life in years. Annual depreciation equals life in years original cost plus repair cost scrap value. Substituting the given values into the formula, we get annual depreciation equals 10,833.33 per year. Annual depreciation equals 12150,000 plus 020,000 equals 10833.33 per year. The total depreciation after 6 years is calculated as total depreciation after 6 years equals 6 multiplied by annual depreciation equals Rs 0.64999.98. Total depreciation after 6 years equals 610,833.33 equals Rs 0.64999.98. The book value after 6 years is calculated as book value after 6 years equals 150,000 minus 6 multiplied by 10,833.33 equals 85,000.02 rupees. An engineer purchased equipment for 1 million rupees and incurred an additional expense of 300,000 rupees for installation and other costs. The salvage value of the equipment is 15% of the initial cost. The book value at the end of 7 years, using the straight line method of depreciation, is 333,125 rupees. We are asked to compute the useful life of the equipment in years. Given data. Original cost equals 1 million rupees. Repair cost equals 300,000 rupees. Scrap value equals original cost plus repair cost, multiplied by 15% equals 1,300,000 rupees multiplied by 15 divided by 100 equals 195,000 rupees. Book value at the end of 7 years equals 333,125 rupees. We know that the book value is calculated as the total cost minus the product of the annual depreciation and the number of years. So, we have 333,125 equals 1,300,000 minus 7 multiplied by annual depreciation. Solving this equation, we find that the annual depreciation is 138,125 rupees. The formula for annual depreciation is: annual depreciation equals original cost plus repair cost minus scrap value divided by life in year. Annual depreciation equals life in years original cost plus repair cost scrap value. Substituting the given values into the formula, we get 138,125 equals 1,300,000 minus 195,000, divided by life in years. Solving this equation, we find that the useful life of the equipment, denoted as N, is 8 years. Thank you. We will continue with the remaining two methods in the next videos.